In the quiet city of Würzburg, Germany, on a cold December day in 1901, a child was born who would one day change the way humanity understood the universe. His name was Werner Heisenberg. From the very beginning there was a spark about him, a curiosity that seemed to stretch beyond the ordinary limits of childhood wonder. His father, a scholar of Greek philology, surrounded the young Werner with books, philosophy, and discussions about ancient wisdom. His mother, known for her gentle nature, nurtured in him a sense of discipline and moral grounding. Together they created an environment that balanced intellect with introspection. As a boy, Werner's world was filled with questions: why stars shimmered, why light moved, and why the laws of nature seemed both orderly and mysterious. Even before he understood mathematics, he felt an invisible structure guiding everything he observed. This quiet fascination became the rhythm of his early life. When the First World War broke out, Heisenberg was still a student, too young to fight but old enough to feel the tremors of chaos it unleashed. His education, like the rest of Germany, was interrupted by scarcity and uncertainty. Yet, within this turbulence, he found something that would shape him forever: resilience. While his classmates were distracted by politics and survival, Heisenberg immersed himself in problems of mathematics and geometry. He discovered that numbers could create harmony where the world outside was collapsing. His teachers noticed a mind that worked differently, a mind that could see patterns where others saw confusion. Heisenberg's ability to visualize complex relationships without needing to draw or calculate every detail became his defining gift. It was not just intelligence, it was intuition, a deep sense that the universe spoke in a language he was beginning to understand. By his teenage years, Heisenberg was already drawn toward the mysteries of physics. He devoured the works of great scientists like Helmholtz, Planck, and Einstein, though he barely understood the equations at first. What fascinated him most was not the results but the ideas, the thought that reality could be explained through laws both precise and profound. When he joined the University of Munich in 1920, he came under the guidance of Arnold Sommerfeld, one of Germany's most respected physicists. Sommerfeld immediately recognized something unusual in his new student. Heisenberg was not content with the answers found in textbooks. He wanted to know the assumptions behind them. He questioned why electrons behaved as they did, why light could act both like a wave and a particle, why certainty seemed to vanish at the smallest scales. In the lectures, he often challenged established explanations, not out of arrogance, but out of a relentless hunger to understand what others overlooked. The young Heisenberg's talent was not confined to science alone. He was an accomplished pianist, finding in music the same sense of order and mystery that he saw in mathematics. To him, a Bach fugue and a quantum equation shared something profound. Both followed invisible harmonies. He could spend hours at the piano, lost in melodies, only to return to his studies with renewed insight. It was as if his mind drew strength from beauty. This synthesis of art and logic would later help him approach physics not just as calculation, but as creation. To Heisenberg, science was not merely the discovery of facts, it was the unveiling of deeper connections between the seen and unseen, the measurable and the imaginable. In 1922, Heisenberg visited Göttingen, a university that had become the beating heart of modern theoretical physics. There, he encountered Max Born, a man whose mathematical precision complemented Heisenberg's intuitive daring. Born saw in Heisenberg a rare mixture of youthful energy and profound thought. Their conversations often stretched late into the night, filled with debates about atoms, waves, and the emerging paradoxes of quantum theory. It was here that Heisenberg met other rising minds: Wolfgang Pauli, Pascual Jordan, and later Niels Bohr, each destined to play a role in shaping the new science. They were all part of a generation standing at the edge of an intellectual revolution. Classical physics, which had explained everything from planetary motion to electricity, was beginning to fail at the atomic level. The world of electrons defied logic, and no one knew why. Heisenberg's health during these years was fragile. He often suffered from allergies and exhaustion, sometimes collapsing after long periods of work, but even illness could not keep him from his passion. When his lungs weakened, he took refuge in the mountains of Bavaria, where the crisp air helped him recover. He loved to climb, to push himself to the summit, where the world below seemed distant and the sky infinite. Those moments of solitude among the peaks mirrored his journey in science. The climb was difficult, the path uncertain, but at the top there was clarity. Many of his later ideas, he would recall, came not from the laboratory but from these silent heights where thought flowed freely, unburdened by convention. In 1923, Heisenberg completed his doctoral thesis under Sommerfeld, but his restless mind was already far beyond the typical boundaries of a student. His interest was drawn to the quantum puzzles surrounding atomic spectra, the strange, discrete lines of light emitted by elements when excited. Classical physics could not explain why these lines appeared in specific patterns. Niels Bohr had proposed that electrons moved in quantized orbits, jumping from one level to another without passing through the space in between. It was a bold idea, yet incomplete. Heisenberg saw the problem differently. He was not interested in orbits that could never be seen. He wanted to focus only on quantities that could be directly measured. This conviction, to rely solely on observable phenomena, became the philosophical foundation of his later work. In the summer of 1924, Heisenberg visited Bohr's Institute for Theoretical Physics in Copenhagen. This visit would change his life forever. Bohr was more than a scientist. He was a thinker who viewed physics as a dialogue between man and nature. Under Bohr's mentorship, Heisenberg found both challenge and inspiration. They spent endless hours debating the nature of reality, sometimes walking through Copenhagen's parks until dawn. Bohr admired Heisenberg's sharp intellect, but often pushed him to think deeper, to confront the contradictions within his ideas. Their discussions were not always peaceful. Both were stubborn, passionate, and utterly devoted to truth. Yet from this intellectual friction, a new light began to emerge. Heisenberg's thoughts started to crystallize into something revolutionary. But before the revelation came, there was darkness. In 1925, Heisenberg fell seriously ill with hay fever, forcing him to retreat once again to the North Sea island of Helgoland. There, isolated from friends and laboratories, he found himself alone with the sea, the stars, and his thoughts. Nights were long, filled with the rhythmic pounding of waves against the rocks. He had no books, no notes, just a notebook, and his determination. It was during those sleepless nights that his mind reached its breaking point, and then broke through. He began to imagine a physics without pictures, without the classical visualization of particles moving in space. Instead, he constructed a world of pure relationships, mathematical quantities representing transitions between states of energy. It was as if he had entered the hidden architecture of reality, where numbers replaced trajectories and probabilities replaced certainties. By morning, he had written the first version of what would become matrix mechanics, the birth of quantum mechanics as a true mathematical theory. When Heisenberg returned to Göttingen and showed his work to Born, the older physicist immediately recognized its brilliance. The equations were difficult, even strange, but they captured the essence of quantum behavior with unprecedented accuracy. Born and his student Pascual Jordan refined Heisenberg's formulation into a complete system, creating the first consistent framework for quantum physics. Heisenberg was only 24 years old. The paper they published in 1925 would change science forever, but Heisenberg himself was almost unaware of the magnitude of what he had done. To him, it was simply the next logical step in understanding nature. What others saw as radical, he saw as inevitable. This achievement did not come from chance. It was the culmination of years of struggle, solitude, and relentless thought. Heisenberg had learned to trust the invisible, to follow intuition where logic faltered. He often said that his mind worked like music. Ideas came not as step-by-step reasoning, but as harmonies that suddenly resolved into clarity. His equations were like symphonies, composed not on a page but in the silence of his imagination. Those who met him described his eyes as intense yet distant, as if he were always half listening to something beyond ordinary perception. In conversations he could shift from deep physics to philosophy to poetry without pause. He saw no boundaries between disciplines. To him, all were expressions of the same truth. By the time he received his doctorate, Heisenberg's reputation had spread across Europe. He was invited to conferences, met with Einstein, and became a central figure in what was then called the quantum generation. Yet, even among his peers, he remained something of a mystery. Heisenberg did not seek fame or recognition, he sought understanding. While others might boast of their discoveries, he spoke quietly, often lost in contemplation. His humility masked a mind that could, at any moment, reshape the very structure of thought. Those who studied under him sensed this duality, a man both grounded and transcendent, rooted in mathematics yet reaching for metaphysics. In these early years, before fame and controversy, before uncertainty became his symbol, Werner Heisenberg had already begun to redefine what it meant to be a scientist. He saw the pursuit of knowledge, not as conquest but as communion, a dialogue with nature where the answers came only to those who asked with both intellect and reverence. His journey from a curious boy in Würzburg to the creator of quantum mechanics was not a straight path. It was a climb through confusion, beauty, and isolation. Yet every step led him closer to the truth that would one day make him the architect of the quantum revolution. The success of Heisenberg's 1925 paper was like a sudden thunderclap in the world of physics. Few people at that time could fully understand what he had done, and yet everyone sensed that something extraordinary had taken place. It was as though someone had quietly redrawn the map of reality, and now all of science had to find its bearings again. When Heisenberg returned to Copenhagen, he was greeted not as a student, but as a colleague, an equal among giants. Niels Bohr was astonished by the young man's courage to abandon visualization altogether, to let mathematics describe what the human mind could no longer picture. "You have done something very great," Bohr told him, "but you must also help us understand what it means." The challenge that followed was not to refine the equations but to interpret them, to explain what kind of world such a theory implied. That question would consume Heisenberg's life for decades to come. Heisenberg's early fame brought both exhilaration and weight. He was now seen as a representative of a new era in science, one that replaced determinism with probability, certainty with uncertainty, and visualization with abstraction. Yet Heisenberg himself was not a revolutionary by temperament. He was gentle, thoughtful, almost shy. In his letters from this period, he often wrote about his longing for simplicity, for quiet evenings, music, and walks by the water. But history had chosen him to stand at the frontier of knowledge, and he carried that responsibility with grace. At only 24, he began lecturing across Europe, his ideas sparking both admiration and confusion. Many older physicists dismissed quantum mechanics as mathematical trickery, but the younger generation rallied around him. To them, Heisenberg represented the courage to think beyond the visible. His collaboration with Born and Jordan deepened. Together they worked to connect the abstract formalism of matrix mechanics with experimental reality. The equations predicted atomic behavior with astonishing accuracy. They explained why electrons emitted light at specific frequencies, why atoms were stable, and why the classical view of continuous motion failed. But Heisenberg's mind did not rest. He was troubled by what these equations said about nature itself. If reality could only be described in terms of probabilities, what did that mean for the concept of truth? If measurement altered the system being observed, could one still speak of an objective world existing independently of us? These were not just technical questions. They were philosophical tremors shaking the foundation of science. In 1926, Erwin Schrödinger published his wave equation, an alternative but equivalent formulation of quantum mechanics. It was elegant, visual, and easier to grasp than Heisenberg's matrices. Suddenly, the physics community was divided. Schrödinger's approach seemed to restore the comfort of classical intuition, allowing physicists to picture electrons as standing waves rather than mysterious operators. Heisenberg, however, remained firm. To him, the equations of matrix mechanics were not just another language. They reflected a deeper truth about the nature of the universe. Reality, he argued, was not composed of particles moving through space, but of transitions, interactions, and measurable quantities. The two theories were later proven equivalent, but their philosophical differences marked one of the most profound intellectual debates of the century. During this period, Heisenberg became a central figure in Bohr's Copenhagen Circle, a gathering place for the most brilliant physicists of the time. Every week, Minds like Pauli, Dirac, and Fermi joined the discussions, filling the rooms with smoke, chalk dust, and relentless questions. The air itself seemed charged with discovery. Bohr's home became a laboratory of ideas, where arguments could last until dawn. Heisenberg thrived in this atmosphere. He loved the tension between theory and doubt, between logic and imagination. It was here that his next great insight was born. In trying to understand the limitations of measurement, he realized that there was a fundamental barrier in the very act of observing. The more precisely one tried to determine a particle's position, the less precisely one could know its momentum. This was not a matter of technological limits, but of nature's fabric itself. In 1927, Heisenberg published what he called the uncertainty principle, a concept that would make him immortal in the history of science. The principle was simple in its expression, yet profound in its implications. It shattered the last remnants of classical determinism. The universe, Heisenberg declared, was not a clock that ticked predictably, but a realm of probabilities where observation and reality intertwined. The consequences were staggering. Causality, once sacred in science, was now subject to chance. Observation was no longer passive but participatory. The very act of measurement changed the outcome. When Einstein read Heisenberg's paper, he was deeply unsettled. "God does not play dice," he famously remarked, rejecting the notion that randomness governed the universe. But Heisenberg saw it differently. To him, uncertainty was not chaos. It was the natural language of creation. It was the rhythm of the quantum world, where order emerged not from predictability but from harmony within probability. Heisenberg's fame soared. He was invited to conferences across Europe and America, honored with awards, and hailed as one of the brightest minds of his generation. In 1932, he was awarded the Nobel Prize in Physics for the creation of quantum mechanics. Yet he remained humble, almost detached from the recognition. When reporters asked him how it felt to win, he said softly, "I am still trying to understand what the theory truly means." That was the essence of Heisenberg. His curiosity was never satisfied, his questions never ceased. To him, the universe was an ever-deepening mystery, and every discovery only expanded the horizon of the unknown. Despite his scientific triumphs, Heisenberg's personal life was marked by loneliness and contemplation. He spent long nights writing in his journals about the relationship between science and faith, about the moral duty of knowledge, and about the beauty of the universe. He often quoted Goethe, speaking of light not only as a physical phenomenon but as a symbol of understanding. Music remained his refuge. After intense periods of work, he would sit at the piano, losing himself in Mozart or Beethoven, letting sound become a form of meditation. Those who knew him described a man who carried a quiet intensity, as though he were forever listening to the hidden vibrations of reality. As the 1930s unfolded, the world darkened once more. The rise of the Nazi regime in Germany placed Heisenberg in a perilous position. Many of his colleagues fled, Einstein to America, Born to England, Pauli to Switzerland. Heisenberg, however, chose to stay. He saw himself as a custodian of German science responsible for preserving the spirit of research through the storm. It was a decision that would haunt him. Branded by Nazi ideologues as a white Jew for teaching the theories of Einstein, he endured public attacks and political scrutiny. He survived only because of his reputation and the quiet protection of sympathetic officials, yet he continued to teach, to write, and to think, even as the world around him fell apart. When World War II began, Heisenberg found himself drawn into the German atomic project. As one of the few physicists remaining with expertise in nuclear theory, he was placed in charge of research into uranium fission. His role in this program remains one of the most debated chapters of his life. Some historians believe he deliberately avoided building a bomb, steering the research toward power generation rather than weapons. Others argue that he simply miscalculated the technical requirements. Whatever the truth, Heisenberg's conscience weighed heavily on him. In his letters after the war, he wrote of those years as a time of moral trial, a period where science and responsibility clashed in the darkest way imaginable. He often reflected on the words of his mentor Bohr, who had fled Denmark under Nazi occupation. Every step of science demands not only intelligence but conscience. Heisenberg knew that more than anyone. After the war, Heisenberg was detained by Allied forces and taken to England as part of Operation Epsilon, along with other German scientists. In the transcripts of their secret conversations, Heisenberg comes across as both brilliant and burdened. He spoke openly about the limits of knowledge and the responsibility of scientists. When news of the atomic bombings of Hiroshima and Nagasaki reached them, Heisenberg was shaken. He realized that humanity had crossed a threshold, that the same physics which had revealed the beauty of the atom had now unleashed its horror. From that moment on, his life's mission shifted. He no longer sought only to understand the world, he sought to ensure that understanding served life rather than destruction. Upon his return to Germany, Heisenberg dedicated himself to rebuilding the nation's scientific community. He helped establish institutes, reformed universities, and mentored a new generation of physicists. His lectures during these years were filled with both brilliance and humility. He spoke not only of particles and equations, but of the moral dimension of discovery. He believed that science and spirituality were not enemies, but reflections of the same human yearning for truth. "The first sip from the glass of natural science," he once said, "may make one an atheist, but at the bottom of the glass God is waiting." This quote would become one of his most famous, encapsulating his belief that the deeper one delved into the fabric of reality, the closer one came to a transcendent order beyond comprehension. In his later years, Heisenberg turned increasingly to philosophy, exploring the parallels between quantum mechanics and ancient metaphysics. He wrote about Plato's ideas of ideal forms, about the relationship between language and perception, and about the unity of opposites that defined both nature and thought. His writings revealed a man who had moved beyond the boundaries of physics into the realm of wisdom. Yet, he never abandoned his scientific rigor. He continued to publish, to debate, and to engage with younger thinkers, always reminding them that true discovery required humility before mystery. As his health declined, Heisenberg often returned to the mountains that had inspired him in youth. Standing on a peak, looking out at the horizon, he would reflect on the long path that had brought him there, from the boy who wondered at the stars to the man who deciphered their quantum essence. He had lived through wars, revolutions, and moral storms, yet his faith in the beauty of nature remained unshaken. In his final interviews, he spoke of harmony, the harmony between science and soul, between reason and reverence. "We are part of the universe," he said softly, "and the universe is part of us. The act of knowing is an act of participation." Werner Heisenberg passed away in 1976, leaving behind not just equations but a philosophy of life. His work remains the cornerstone of modern physics. His ideas power everything from computers to lasers to our understanding of the cosmos. Yet his true legacy lies in the way he taught humanity to think, to accept uncertainty, to see beauty in ambiguity, and to find truth not in absolute answers but in the endless pursuit of understanding. The story of his life is the story of the human spirit itself, daring, searching, questioning, and forever reaching toward the light that flickers beyond the horizon of certainty. Through every equation he wrote, every principle he proposed, Heisenberg built more than a scientific theory. He built a bridge between the known and the unknown, and on that bridge he stood alone at times, gazing into the invisible structure of creation, knowing that he had glimpsed the architecture of existence itself. The mid-1920s were a time of both confusion and brilliance in the world of physics, a moment when the most brilliant scientific minds of the century were wrestling with questions that no experiment seemed able to answer. The classical world, built upon the certainties of Newton and Maxwell, was collapsing under the weight of discoveries that defied logic. Atoms emitted energy in strange, discontinuous bursts. Electrons refused to stay in predictable orbits. Light behaved sometimes like a wave, sometimes like a particle, as though nature could not make up its mind. For young Werner Heisenberg, these paradoxes were not obstacles to fear, but doorways into a deeper reality. He felt, almost instinctively, that the universe was inviting humanity to think differently, to abandon the comfort of pictures and step into the raw mathematics of nature itself. The stage was set for the birth of quantum mechanics, and Heisenberg was about to become its architect. In 1924, Heisenberg was a restless 23-year-old physicist torn between faith in reason and frustration with its limits. The Bohr model of the atom, elegant as it was, could not fully explain the mysterious patterns of light observed when atoms were heated or electrified. When Heisenberg looked at the data, the spectral lines produced by hydrogen, he saw something both haunting and tantalizing. The colors emitted were not random. They were arranged in exact, repeating sequences that hinted at an underlying mathematical order. Yet every attempt to describe the motion of electrons in space led to contradictions. The orbits imagined by Bohr worked as metaphors but failed as measurements. To Heisenberg, it was time to throw away the metaphors. We must not ask what an electron is doing between observations, he would later say. We must ask only what can be observed. It was a radical statement, almost heretical in a field obsessed with visualizing nature. But it was in this renunciation of imagery that a revolution began. By early 1925, Heisenberg was in Copenhagen, working under Niels Bohr, whose institute had become the mecca of theoretical physics. Their conversations were intense, filled with long pauses and sudden bursts of insight. Bohr encouraged Heisenberg to push beyond the boundaries of imagination. "What we observe is not nature itself," Bohr often said, "but nature exposed to our method of questioning." These words echoed in Heisenberg's mind. If observation defined reality, then perhaps the old idea of particles moving along paths was meaningless. Perhaps what truly mattered were the transitions, the jumps between energy levels that produced the observed spectra. The problem was how to describe these transitions mathematically. Every attempt seemed to collapse under its own complexity. Then, in June of that year, Heisenberg fell ill with a severe bout of hay fever and retreated to the remote North Sea island of Helgoland to recover. It was there, isolated from libraries and colleagues, surrounded by the endless wind and sea, that his mind finally found clarity. The island was quiet, its cliffs battered by the waves. Heisenberg spent his days walking along the shore, thinking, scribbling in his notebook, and watching the light change across the horizon. At night, under a sky full of stars, he returned to his equations. He realized that if one could only describe the relationships between observable quantities, the frequencies and intensities of light emitted, then the need to imagine electron paths would disappear. He began replacing classical variables like position and momentum with tables of numbers representing possible transitions between energy states. These arrays could not be multiplied in the ordinary way. The order of multiplication mattered. That strange property, which mathematicians called non-commutativity, turned out to be the key. Without fully knowing it, Heisenberg had stumbled upon matrix algebra, a branch of mathematics that would become the backbone of quantum theory. Night after night, he worked by the dim light of a lamp, filling pages with calculations. The air was salty and cold, his body weak, his mind feverish with inspiration. At last, in a burst of clarity, he saw the structure take shape. The observable quantities of an atom could be represented as matrices, mathematical grids of numbers that encoded the probabilities of transitions. The equations he derived described the spectra of hydrogen perfectly, matching experimental data without ever invoking imaginary orbits. It was pure mathematics, stripped of all physical imagery. And yet it described nature more accurately than any visual model ever had. As dawn broke over the sea, Heisenberg realized he had crossed a threshold. He had built a new physics, one that dealt not in certainties, but in patterns of possibility. When he returned to Göttingen a few weeks later, Heisenberg rushed to share his discovery with Max Born, his mentor and collaborator. Born was astonished but puzzled. The calculations worked, but their structure was alien to anything known in physics. Only when Born recognized that Heisenberg's strange tables obeyed the rules of matrix multiplication did the full magnitude of the breakthrough become clear. Born and his assistant, Pascual Jordan, helped formalize the theory, translating Heisenberg's intuition into rigorous mathematics. Together they published their results in 1925 under the title On the Quantum Mechanics of Kinematic and Mechanical Relations. The paper was dense, abstract, and revolutionary. Many who read it struggled to comprehend its meaning, but those who did knew that physics would never be the same. Heisenberg's matrix mechanics did something profound. It replaced the deterministic language of trajectories with a probabilistic language of transitions. Instead of describing how a particle moves, it described how one measurable quantity relates to another. The world it depicted was not a machine, but a symphony of probabilities. For the first time, scientists had a theory that matched experimental results perfectly, even though it defied every classical intuition. The old picture of an atom as a miniature solar system vanished, replaced by a mathematical structure that existed only in abstraction. The universe, it seemed, was not made of solid objects, but of relationships, of numbers dancing in harmony. At first, many physicists resisted. Schrödinger, who would soon propose his own wave mechanics, dismissed Heisenberg's work as incomprehensible symbolic algebra. Even Einstein, while admiring the young man's genius, felt uneasy about abandoning visualization, but for others, the new theory was a revelation. Wolfgang Pauli praised Heisenberg's courage to discard imagery and rely purely on mathematics. Paul Dirac, then a young student, extended the theory with breathtaking elegance, blending it with relativity to form the basis of modern quantum field theory. What Heisenberg had done was more than create a new set of equations. He had redefined the meaning of physical reality itself. Heisenberg himself felt a mix of triumph and doubt. He often wondered whether his abstract formalism described something real or was merely a mathematical trick. In letters to Bohr, he confessed that he could not visualize what his equations meant in physical terms. Bohr reassured him that visualization was no longer necessary, that science had entered a new age where logic and observation, not imagination, would guide discovery. Together, they refined the philosophical foundation of quantum theory, eventually formulating what came to be known as the Copenhagen interpretation. It proposed that the act of measurement collapses a system's multiple possibilities into a single outcome, meaning that nature is fundamentally probabilistic until observed. This idea, radical and unsettling, grew directly out of Heisenberg's work. The atmosphere among the quantum pioneers during this period was electric. Letters flew across Europe, carrying equations, arguments, and philosophical reflections. Conferences turned into battlegrounds of ideas. In 1926, Schrödinger introduced his wave equation, offering a more intuitive picture of quantum phenomena. For a brief moment, it seemed as if his wave mechanics might replace Heisenberg's matrices, but within months, the equivalence of the two theories was proven. They were two languages describing the same reality, one visual, one abstract. The victory was not of one approach over the other, but of the quantum worldview itself. Classical physics, which had ruled for centuries, was dethroned. Amid all this, Heisenberg's personal life remained simple, almost ascetic. He lived in small rooms, ate little, and spent his days buried in thought. His friends joked that he lived half in the real world and half in the quantum one. He had little patience for comfort or social status. What drove him was not fame, but the desire to understand. When he lectured, his voice was soft but intense, his gestures precise. Students described the experience as both terrifying and exhilarating. They felt as if they were witnessing a mind at the edge of creation. Heisenberg never read from notes. He spoke as if the equations themselves were unfolding before him, alive in his imagination. As word of his theory spread, Heisenberg was invited to give talks across Europe. In Leiden, Zurich, and London, physicists gathered to hear the young German who had rewritten the laws of nature. Some left those lectures confused, others inspired, but none remained indifferent. Heisenberg's calm, clear explanations contrasted with the abstract complexity of his equations. He spoke of the beauty of simplicity, of the need to focus on what could be known and to accept what could not. To many, he seemed more like a philosopher than a scientist. In truth, he was both. A thinker who saw equations not as tools, but as windows into reality. By 1927, Heisenberg's work had evolved beyond mathematics into philosophy. He began to explore what his theory meant for the nature of knowledge itself. If the observer could not separate from the observed, then objectivity was not absolute. Knowledge was relational. This realization would soon crystallize into his famous uncertainty principle, but even before that, its seeds were present in the fabric of matrix mechanics. Each calculation, each probability, implied a limit to what could be known. Heisenberg was among the first to recognize that these limits were not weaknesses, but reflections of nature's true form. The universe, he thought, was not hiding its secrets. It was whispering them through the language of uncertainty. Even as he gained fame, Heisenberg remained remarkably modest. He continued to spend his free time hiking in the Alps or sailing on lakes, seeking silence after the noise of conferences. He found in nature the same patterns he saw in his equations, the harmony of opposites, the interplay of order and randomness. To him, the quantum world and the physical world were not separate but mirrors of one another. Both were expressions of a deeper unity he could feel but not yet define. "I think," he once wrote, "that the joy of discovery lies not in the finding of answers, but in the enlargement of the mystery." By the end of 1925, physics had crossed a threshold from which it could never return. The old mechanical view of the universe was gone. In its place stood Heisenberg's quantum mechanics, a framework that defied visualization yet explained everything from atomic spectra to chemical bonds. It was as if a veil had been lifted, revealing a universe made not of things but of interactions, not of certainties but of probabilities. Heisenberg had given humanity a new way of seeing, one that would shape the course of science for generations. In the wake of his breakthrough, Heisenberg's discovery began to ripple outward, touching every corner of the scientific world. The paper that had seemed so abstract, so alien in its mathematical form, was now being studied line by line in universities and laboratories across Europe. At first, it bewildered even the most brilliant minds. Many physicists could not grasp what it meant for something as concrete as matter to be described by non-commuting matrices, numbers that refused to behave by the old rules. Yet those who persisted soon realized that Heisenberg had given them something far greater than a new tool. He had given them a new way to think. The birth of quantum mechanics was no longer a theory to explain oddities. It had become the new foundation upon which the future of science would be built. Heisenberg, meanwhile, was still adjusting to what he had done. In private letters, he admitted that he often woke in the night with a strange mixture of awe and disbelief. He wondered how such an idea could have come through him, as though it had been waiting for him rather than invented by him. The world he had revealed was not mechanical but musical, a universe where particles followed the rhythms of probability, where harmony replaced certainty. His colleagues soon began to explore the implications of this revelation. Paul Dirac used Heisenberg's algebra to create a new form of quantum theory that merged it with relativity, predicting phenomena that had never been seen before. Pauli, always sharp and skeptical, found himself persuaded by the power of Heisenberg's equations, using them to calculate properties of atoms that experiments soon confirmed. It was as if the universe itself had been holding its breath, waiting for someone to listen in the right mathematical key. But for Heisenberg, the excitement was always intertwined with doubt. He had built a theory that worked with astonishing precision, yet he could not visualize what it meant. When he spoke of the electron, he no longer pictured a particle orbiting a nucleus. He thought in terms of matrices, symbols, and frequencies. The old imagery had vanished. In this new landscape, there was only interaction and measurement. Heisenberg knew this would be difficult for others to accept. Humans were used to seeing, touching, and imagining, but the quantum world could not be seen. It could only be inferred. This was not a flaw, but the essence of nature itself. Reality, as he now understood it, was not a solid structure waiting to be discovered, but a web of relationships coming into existence through observation. The years that followed turned Copenhagen into a pilgrimage site for physicists. Every month, trains arrived carrying young scientists eager to hear Heisenberg and Bohr discuss their strange new vision of the universe. Inside Bohr's institute, chalk dust filled the air as ideas collided like particles. Bohr, calm and philosophical, urged caution and reflection. Heisenberg, quick and intense, drove the discussions forward with bursts of clarity. Their debates often spilled into the streets and cafes, lasting long into the night. There was a sense that they were not just solving equations, but unraveling the very meaning of existence. When Heisenberg tried to explain matrix mechanics to visiting scientists, he used analogies drawn from music, light, and logic. never from physical pictures. He spoke of energy levels like musical notes, each capable of shifting in discrete steps. The universe, he said, was quantized harmony. In 1926, Erwin Schrödinger's wave mechanics appeared, giving physicists a more familiar language in which to think. Instead of matrices, Schrödinger described electrons as standing waves, smoothly oscillating in space. His equation produced the same results as Heisenberg's, but seemed to restore some of the lost intuition. For a moment, the scientific community leaned toward the wave view, comforted by its imagery. Yet Heisenberg was unshaken. He saw in Schrödinger's model an illusion of concreteness, a return to visualization that could never truly capture the essence of the quantum world. In discussions with Bohr, he argued that while waves might provide a useful picture, they did not represent physical reality any more than his matrices did. The truth lay deeper, beyond the reach of imagery. In time, the equivalence of both approaches was proven, and quantum mechanics stood firm, a union of two languages describing one invisible reality. By now, Heisenberg's reputation had grown beyond measure. Invitations poured in from universities around the world. He traveled across Europe, lecturing to packed halls, his name spoken with the same reverence once reserved for Newton and Einstein. Yet behind the public acclaim, he remained quietly unsettled. During his travels, he often carried a small notebook where he sketched thoughts not only about physics but about philosophy, ethics, and the human condition. He was haunted by the question of what it meant for human beings to live in a universe that was no longer certain. If the foundations of nature were governed by probability, what did that say about free will, about cause and effect, about the meaning of order? Heisenberg did not see uncertainty as chaos, but as a sign of something profoundly interconnected, an order so subtle that it appeared random only because human perception was too limited to see the whole pattern. As Heisenberg continued to refine his ideas, his relationships with his colleagues deepened. With Max Born, he shared long evenings of mathematical exploration, both men marveling at the power of abstract reasoning to reveal physical truth. With Pauli, the conversations were sharp and challenging, filled with laughter and argument. With Bohr, the dialogue was almost spiritual. The older man often pushed Heisenberg to think about the philosophical implications of his discoveries. One evening, walking along the waterfront in Copenhagen, Bohr told him, "When it comes to atoms, language can only be used as in poetry." Heisenberg never forgot those words. They captured perfectly what he felt, that the equations of quantum mechanics were not mere calculations, but a new kind of poetry, written in the symbols of mathematics, expressing truths too deep for images. In 1927, Heisenberg's reflections culminated in the discovery of the uncertainty principle. It was, in many ways, a natural outgrowth of matrix mechanics, a recognition that the properties of subatomic particles could not be known simultaneously with perfect precision. The act of measuring one quantity inevitably disturbed the other. To the public, this idea seemed shocking, even mystical, but to Heisenberg it was a logical extension of what his mathematics had already revealed. The universe was not a clock, it was a conversation between possibility and observation. This insight transformed quantum mechanics from a collection of equations into a philosophical framework, one that redefined the meaning of knowledge itself. The following years were among the most productive of Heisenberg's life. He published paper after paper, each deepening the structure of quantum theory. He began exploring the atomic nucleus, predicting properties of particles that would not be discovered until decades later. Everywhere he went, students followed, eager to learn from the man who had opened the door to the invisible world. Heisenberg's lectures were unlike any others. He did not simply teach equations, he told stories. About light, symmetry, and the struggle to think without images, he spoke of the joy of discovery and the humility it required. In the face of nature, he once told a class, "We are not conquerors but listeners." By 1932, the full impact of Heisenberg's work was undeniable. He was awarded the Nobel Prize in Physics for the creation of quantum mechanics, becoming, at only 31, one of the youngest laureates in history. At the ceremony in Stockholm, he appeared calm but introspective. In his speech, he spoke not of triumph but of mystery. He thanked his mentors and collaborators, and then said quietly, The more precisely we understand nature, the more deeply we are aware of its harmony. Those words captured the essence of his vision. That behind the apparent randomness of quantum events lay a profound order, one that could be felt but never fully known. Yet even as he stood at the height of fame, Heisenberg's thoughts turned inward. He sensed that quantum mechanics had not just changed science, it had changed humanity's relationship with truth. The certainty that had defined centuries of scientific progress was gone. In its place was humility, the acknowledgement that knowledge had limits. Heisenberg saw this not as defeat, but as liberation. It meant that the universe was alive, dynamic, and participatory, that human consciousness itself was woven into the fabric of reality. His vision of physics was no longer mechanical but almost spiritual, a dialogue between the observer and the observed, between thought and existence in the decades that followed. As new discoveries built upon his foundation, Heisenberg watched with quiet pride and occasional concern. Quantum mechanics had given birth to technologies beyond imagination, semiconductors, lasers, nuclear power, but also to questions about the ethical responsibilities of science. He continued to teach, to write, and to speak about the unity of knowledge, urging his students to remember that understanding without wisdom was dangerous. For Heisenberg, the true purpose of science was not control but wonder, the perpetual deepening of the mystery that lay at the heart of creation. Looking back across his life, one can see that the birth of quantum mechanics was not simply the product of intellect but of courage, the courage to think differently, to abandon the familiar, to face the unknown without fear. In those sleepless nights on the island of Helgoland, as waves crashed against the rocks and the stars shimmered above Werner Heisenberg had glimpsed a truth that would reshape the world. He had seen that reality was not a static structure but a living symphony, and that humanity's role was not to master it, but to listen, to measure, to participate in its unfolding. Through him, the universe had found a new voice, one that spoke in probabilities and patterns, in uncertainty and harmony. And through that voice, Heisenberg became what history would remember him as: the architect of the quantum revolution, the man who taught the world to see the invisible and to accept that in the heart of uncertainty lies the deepest truth of all. In the years following the birth of quantum mechanics, Werner Heisenberg found himself at the center of a storm unlike any the scientific world had ever seen. His matrix formulation had rewritten the laws of physics, yet it had also raised questions that went far beyond equations. The mathematics worked, but what did it mean? What kind of reality did it describe? Was nature truly random, or was there an order hidden beneath the veil of probabilities? These were not just technical puzzles, they were philosophical earthquakes shaking the foundations of certainty itself. For Heisenberg, the challenge was no longer to create the theory, but to understand the world it revealed. The deeper he went into the quantum domain, the more he realized that the universe was not merely strange, it was fundamentally unknowable in the way human intuition demanded. By 1926, the air of European physics was thick with debate. Schrödinger's wave mechanics had joined Heisenberg's matrix mechanics, and although the two approaches were mathematically equivalent, they seemed to represent two opposing visions of reality. Schrödinger believed in continuity, in smooth undulating waves that spread across space and time. Heisenberg, on the other hand, believed in discreteness, in jumps, in energy quanta that leaped from one state to another without traversing the in-between. To Schrödinger, the wave picture felt elegant and comforting. To Heisenberg it was illusion. He could not accept any image that pretended to show what could not be observed. Their arguments were fierce and sometimes personal, yet beneath the disagreement was a shared quest to uncover what the quantum world was truly saying about existence. Heisenberg spent endless nights in thought, walking the quiet streets of Copenhagen after his discussions with Niels Bohr. The city slept, but his mind burned with questions. Bohr's philosophical depth both inspired and frustrated him. Bohr would say that the task of physics was not to discover how nature is, but to describe what can be said about nature. For Heisenberg, this idea was both liberating and terrifying. It meant that science could no longer claim to reveal objective reality. It could only map the boundaries of human knowledge. The more Heisenberg pondered, the more he felt the old concepts of position and motion dissolve into abstraction. If electrons did not travel along paths, then what was motion? If measurements interfered with systems, then what was reality when no one was looking? In the spring of 1927, while recovering from a recurring illness, Heisenberg began re-examining the mathematical structure of quantum theory. His mind, sharpened by solitude, focused on a single paradox. When you tried to measure both the position and the velocity of a particle, something went wrong. The more precisely you knew one, the less precisely you could know the other. This was not an error of instruments or technique, it was something deeper, a limitation written into the fabric of nature itself. Heisenberg began to suspect that the act of observation was not passive but participatory. The electron did not exist as a fixed entity independent of measurement. It came into definition through the process of being observed. He was standing on the brink of an idea that would change not only physics but philosophy forever. Late one night, while working through calculations in Bohr's Institute, the concept crystallized. He realized that the product of the uncertainties in position and momentum could never be smaller than a specific value. It was a limit, absolute and universal. If one tried to pinpoint a particle's position with perfect accuracy, its momentum became infinitely uncertain. Conversely, if one measured the momentum exactly, the particle's location spread out into a wave of possibilities. The universe, he now saw, was not made of solid trajectories but of probabilities, clouds of potential that collapsed into events only when measured. This was the uncertainty principle, though Heisenberg at first called it the indeterminacy relation. When he showed his result to Bohr, the older man was silent for a long time. Finally, Bohr said, "We must be clear. It is not a question of disturbing what we observe, but of defining what can be observed." The principle was revolutionary because it demolished the last pillars of classical determinism. For 3 centuries, science had operated under the belief that if one knew the present state of a system with perfect accuracy, one could predict its future. Laplace's demon, a hypothetical intelligence that could calculate all events from initial conditions, was the symbol of that faith. Heisenberg's insight shattered it. The universe was no longer a predictable machine but a living field of possibilities. The precise moment of an electron's jump, the path of a photon, the decay of an atom, all were governed by probability, not certainty. Reality itself seemed to flicker, existing only when observed. When Heisenberg published his paper in 1927, titled Über den Anschaulichen Inhalt der quantentheoretischen Kinematik und Mechanik, on the perceptual content of quantum theoretical kinematics and mechanics, it sent shockwaves through the scientific community. The mathematics was simple compared to his earlier work, but the implications were staggering. Einstein, upon reading it, was both fascinated and troubled. God does not play dice with the universe, he declared, rejecting the notion that nature could be fundamentally uncertain. But Heisenberg replied that God's dice were not a flaw. They were the essence of the game. What Einstein saw as incompleteness, Heisenberg saw as truth. The world was not incomplete. Human understanding was. As debates erupted across Europe, Heisenberg found himself both praised and criticized. Some hailed him as a visionary who had revealed the hidden logic of the cosmos. Others accused him of abandoning the sacred goal of science, to find objective truth. Yet Heisenberg stood firm. He did not see uncertainty as ignorance, but as a law of nature. The path comes into existence only when we observe it, he would later write. To him, this was not a retreat from reality, but a deeper entry into it. The uncertainty principle was not about what humans failed to know. It was about how reality itself operated. Before knowledge, Heisenberg's discovery did more than rewrite physics. It forced a rethinking of the relationship between man and nature. If observation played a role in shaping outcomes, then the observer could no longer be separated from the observed. The walls between subject and object, between consciousness and matter, began to crumble. Philosophers, theologians, and poets soon found themselves drawn into the discussion. Was reality created by perception? Was consciousness fundamental? Heisenberg himself remained cautious, refusing to drift into mysticism. But he acknowledged that the boundary between science and philosophy had blurred. The uncertainty principle, he believed, was a mirror held up to human understanding, showing both its brilliance and its limits. In those years, Heisenberg's life revolved entirely around his work. He spent long days at the blackboard, deriving equations, and longer nights walking alone through the dark streets of Copenhagen. He was only in his mid-20s, yet he felt decades older. The intellectual pressure was immense. Every conversation, every conference was a battle over meaning. When he visited other physicists, Born in Göttingen, Pauli in Zurich, Dirac in Cambridge, he found the same mixture of excitement and confusion. The quantum revolution was no longer an isolated discovery. It had become a movement, a shift in human perception itself. At conferences, Heisenberg often faced Einstein across the table. Their exchanges became legendary. Einstein would devise thought experiments to expose what he saw as flaws in the uncertainty concept, imagining boxes of light, mirrors, and hypothetical measurements that would, in principle, bypass Heisenberg's limits. Each time, Heisenberg or Bohr found the flaw in Einstein's reasoning. The laws of nature, it seemed, defended their uncertainty. Heisenberg admired Einstein deeply, and often said that their debates were among the greatest experiences of his life. It was like playing chess with the gods, he would later recall. Yet behind their disagreement lay mutual respect. Einstein's resistance forced Heisenberg to refine his ideas, to define the boundaries of his principle with greater precision. In a sense, Einstein was the crucible through which Heisenberg's ideas were forged. Despite his fame, Heisenberg never lost his humility before the mystery he had uncovered. He often said that quantum mechanics taught him reverence for the unknown. When journalists tried to summarize his work as the claim that everything is uncertain, he gently corrected them. It was not that everything was uncertain, it was that certainty had limits. Within those limits, there was beauty, order, and predictability. Beyond them lay the shimmering field of possibilities that gave rise to everything. The world was both determined and free, structured yet open. Heisenberg saw in this duality a reflection of human existence itself. His philosophical depth began to draw attention outside of physics. He was invited to speak at gatherings of philosophers and theologians, where he emphasized the harmony between science and the search for meaning. He argued that quantum mechanics did not destroy causality but redefined it. Events were still connected, but not in the rigid chain imagined by classical physics. Instead, the universe functioned through probabilities that allowed for freedom within order. It was a vision both scientific and poetic, precise yet profoundly human. The years of struggle to interpret the quantum world took their toll on Heisenberg. His health, always delicate, suffered from exhaustion. But even when physically weak, his mind remained luminous. He once said that understanding quantum mechanics was like learning to see the world anew, as if the familiar objects of daily life, chairs, stones, stars, had become transparent, revealing their hidden quantum dance beneath. Everything solid, he realized, was made of uncertainty, and yet that uncertainty was the foundation of stability. It was a paradox he found beautiful, the unpredictable at the heart of the predictable, the invisible shaping the visible. As 1927 turned into 1928, Heisenberg's principle began to permeate all of modern science. Chemists, biologists, and engineers started to see that uncertainty was not a limitation but a framework for innovation. The study of atoms, the development of electronics, the birth of quantum chemistry, all flowed from the equations he had written on a quiet night only months earlier. And yet Heisenberg remained introspective. When asked how it felt to have redefined reality, he answered softly, "We did not change nature. We only discovered that it is more subtle than we thought." In those words lay the essence of his journey. Heisenberg's struggle to interpret the quantum world was not the battle of a scientist against confusion, but the awakening of the human mind to a deeper truth, that knowledge and mystery are not enemies but companions. The uncertainty principle was not an admission of defeat. It was a celebration of the living, breathing complexity of the universe. Heisenberg had looked into the heart of matter and found not chaos, but harmony hidden in indeterminacy. After the publication of the uncertainty principle, Heisenberg's life entered a new phase. The world saw him as the young genius who had dared to redefine reality, but behind the fame, he remained a man consumed by questions. The principle that bore his name was not, to him, a finished discovery. It was the beginning of a deeper mystery. Every time he wrote the equation deltax and deltap greater than or equal to h4pi, he felt both wonder and discomfort. It was such a simple mathematical expression, yet within its symbols lived an entire philosophy of existence. It said that nature itself drew boundaries around human knowledge, that precision was not merely difficult, but fundamentally impossible. For centuries, scientists had believed that the universe was a perfect clock, ticking according to exact laws. Heisenberg had shown that even if one knew the laws perfectly, one could never know the ticking hands completely. The more deeply he pondered it, the more he realized that this principle was not a statement about ignorance, but about the nature of reality itself. As he continued his work, the reactions of the scientific world reached every extreme. Some, like Niels Bohr, saw in Heisenberg's uncertainty a profound truth about the limits of knowledge. Others, like Albert Einstein, viewed it as an incomplete picture, a sign that quantum theory was still hiding a deeper order. Their debates became legendary. Einstein, with his calm conviction, would present thought experiments designed to expose the weaknesses of uncertainty, imagining boxes of light and clocks of infinite precision. Heisenberg would listen carefully, often nervous in Einstein's presence. But when the discussion ended, the equations always stood their ground, no matter how clever the experiment. Nature refused to give up her secrets beyond the limits Heisenberg had set. Bohr would later call these discussions the greatest conversations in the history of physics. But for Heisenberg, they were also personal battles. He revered Einstein as a hero, the man who had changed the world with relativity, and he felt uneasy that his own discovery contradicted Einstein's vision of a rational universe. Heisenberg often wrote in his diary about the emotional strain of disagreeing with his idol, yet he could not deny what the mathematics revealed. In one entry, he described lying awake at night, imagining the motion of an electron as a blur of probabilities, its position nowhere and everywhere until observed. He wrote that it felt as though the universe had become alive, watching back through the eyes that tried to see it. As months turned into years, Heisenberg's thoughts deepened into philosophy. He began to see uncertainty not just as a law of nature, but as a reflection of human existence. Just as particles could not be pinned down without changing them, he felt that people too changed by being observed, by being measured, by being defined. He spoke of this at lectures, describing how knowledge itself was an interaction between the knower and the known. Some listeners thought he was drifting into mysticism, but Heisenberg remained precise, careful to ground every statement in logic. Still, he could not ignore the parallels between science and consciousness. He had found that the universe did not behave as an object independent of mind. It behaved as a dialogue, a relationship. During these years, he worked closely with Bohr to refine the philosophical foundations of quantum theory, developing what became known as the Copenhagen interpretation. It stated that quantum mechanics did not describe an objective reality existing independently of observation. Rather, it described the outcomes of measurements, the probabilities of what could be observed. Before observation, a system existed only as a wave of possibilities. The act of measurement caused it to collapse into one reality. This was an idea that both fascinated and frightened the scientific world. For the first time, human consciousness seemed to play a fundamental role in physics. Heisenberg, though cautious, acknowledged that something deeply mysterious lay in this interaction between observer and observed. In 1929, Heisenberg embarked on a lecture tour through the United States and Asia, bringing the message of the quantum world to audiences far beyond Europe. He spoke at Princeton, Harvard, and Caltech, where young scientists hung on his every word. They expected to hear about equations and particles, but Heisenberg spoke instead of limits and harmony, of how the universe could be both precise and uncertain, both knowable and unknowable. Reporters were puzzled by the humility in his tone. He spoke of nature not as something to be conquered, but as something to be understood through respect and patience. When asked what it felt like to discover the uncertainty principle, he smiled gently and said, "It felt like standing before a great ocean, realizing that the horizon is not the end, but the beginning." Meanwhile, in Europe, quantum mechanics continued to expand like a living organism. Dirac had unified it with relativity, Pauli had introduced exclusion principles that explained atomic structure, and Schrödinger's wave mechanics had been woven together with Heisenberg's matrices into a single coherent framework. Yet through it all, the uncertainty principle remained the heartbeat of the theory, the quiet reminder that even in the most precise equations, there existed a boundary that could not be crossed. Heisenberg often compared it to a horizon. The closer you move toward it, the more it moves away. It was not an obstacle, but a feature of reality's design. By the early 1930s, Heisenberg had achieved global fame. In 1932, he received the Nobel Prize in Physics for the creation of quantum mechanics and for the discovery of its fundamental laws. Standing in Stockholm, accepting the medal, he looked both proud and uneasy. He spoke of the beauty of nature's order and the humility required to study it. Every step in science, he said, deepens our awareness of the harmony between the human mind and the universe. His words were not the triumphal declaration of a conqueror, but the quiet reflection of a philosopher. But as his fame grew, so did the burden of interpretation. The uncertainty principle began to take on meanings that stretched far beyond physics. Philosophers saw in it a metaphor for the limits of human reason. Theologians saw in it a reflection of divine mystery. Artists used it to express the instability of modern life. Heisenberg found himself drawn into conversations that blurred the line between science and spirituality. In his essays, he warned against misusing uncertainty as an excuse for irrationality. The principle, he insisted, was not about chaos, it was about structure, an order so fine that it defied classical description. It revealed that the universe was not built from rigid bricks, but from waves of potential, and that certainty itself was only one mode of understanding among many. Heisenberg's own life mirrored this balance between precision and openness. He continued to teach and research, but he also spent more time in reflection, reading philosophy and classical literature. He was drawn to the writings of Plato and Goethe, finding in their words echoes of the same dualities he saw in nature: light and darkness, form and essence, certainty and wonder. He often said that the greatest lesson of the uncertainty principle was humility, the realization that even at the height of human knowledge, mystery remains. In the 1930s, as political darkness spread across Europe, Heisenberg's scientific serenity was tested. The rise of Nazism forced him into moral and existential dilemmas. Many of his colleagues fled, others were silenced. He chose to remain in Germany, believing that science must survive regardless of politics. But he was soon attacked by Nazi ideologues, who called quantum physics Jewish science because it contradicted their simplistic worldview. They labeled him a white Jew and sought to remove him from his university post. Heisenberg endured humiliation and public attacks, yet he refused to abandon the principles of truth and inquiry. His belief in the universality of knowledge, shaped by his understanding of uncertainty, gave him strength. He knew that truth was not owned by any ideology. It was woven into the very fabric of existence. Through the years of turmoil that followed, Heisenberg often returned to the mountains and lakes of his youth, finding peace in nature's quiet rhythms. There, surrounded by silence, he would think about the interplay between order and freedom, between knowledge and mystery. He saw in the movement of the clouds and the shimmer of water the same patterns he had once glimpsed in the equations of the quantum world. To him, the uncertainty principle was no longer just a scientific law. It was a universal truth, a symbol of life itself. When the war ended, Heisenberg emerged not as a broken man, but as one transformed. He spoke of the need to rebuild not only science, but the human spirit. He urged young scientists to remember that the purpose of knowledge was not domination, but understanding. He reminded them that uncertainty was not a weakness to overcome, but a gift to embrace, a doorway to creativity, humility, and awe. In every act of observation, he told his students, the universe becomes aware of itself. In his later writings, Heisenberg reflected on how the uncertainty principle had shaped his entire view of reality. He saw the universe as a network of relationships, where every event was connected, every observation an act of participation. The old boundary between subject and object had dissolved. In its place stood a new vision of unity. What we observe, he wrote, is not nature itself, but nature exposed to our method of questioning. It was a simple statement, yet it contained the essence of a lifetime's thought, the idea that reality is not a fixed stage but a living dialogue between mind and matter, observer and observed, question and answer. As his health declined, Heisenberg looked back on his life with quiet satisfaction. He had set out as a boy fascinated by the stars, and ended as a man who had redefined their meaning. He had shown the world that beneath the apparent chaos of quantum mechanics lay a profound harmony, one that united physics and philosophy, knowledge and humility. When he spoke of death, he did so without fear, saying that uncertainty was not the end of understanding but its continuation. "The atoms," he once told a friend, "are not the building blocks of matter. They are the symbols of our curiosity." Werner Heisenberg passed away in 1976, but his principle remains alive in every particle that flickers, every wave that interferes, every measurement that collapses possibility into reality. His struggle to interpret the strange new quantum world became humanity's struggle to understand its place within it. Through his work, we learned that uncertainty is not the shadow of ignorance, but the light of truth refracted through the limits of perception. And so, long after the equations have been memorized and the textbooks written, Heisenberg's voice still echoes, calm, brilliant, and eternal, reminding us that to know the universe is not to master it, but to stand in wonder before its infinite, uncertain beauty. The discovery of the uncertainty principle did not end Heisenberg's quest for understanding. It only deepened it. As he continued his journey, he began to reflect on the wider meaning of what his equations implied. Not just for physics, but for the human condition. The idea that nature itself was built on uncertainty forced science to confront something it had long avoided: the limits of human knowledge. For centuries, scientists had believed that by collecting enough data, by measuring more precisely, by observing more deeply, they could uncover the complete order of the universe. But Heisenberg's principle shattered that illusion. It revealed that no matter how perfect our tools became, there was a boundary that could not be crossed. This was not a technological barrier, but a fundamental one. Nature, it seemed, had drawn a line, whispering that knowledge was not infinite. For Heisenberg, this realization was both humbling and liberating. He began to see the uncertainty principle not as a limitation, but as an invitation to look beyond control and prediction, and to embrace understanding as a dialogue with nature rather than a conquest of it. He saw that uncertainty did not mean chaos, it meant balance. The world was stable not in spite of uncertainty, but because of it. Without the delicate play of probabilities at the atomic level, matter itself could not exist. Every star, every breath, every heartbeat was built upon this quiet dance of indeterminacy. To Heisenberg, uncertainty became a symbol of harmony, the fine tension between order and freedom that held the universe together. As he explored the implications of his discovery, Heisenberg found himself moving naturally into the realm of philosophy. He began to ask questions that no longer belong solely to physics. What is reality if it changes when observed? What is knowledge if the act of knowing transforms the known? What is truth if it depends on context and perspective? The old Cartesian dream of a detached observer, the scientist standing outside nature, measuring it from afar, was gone. In its place stood a new vision, the observer and the observed as two parts of the same whole. The universe was not a machine running independently of us. It was a living, participatory field in which consciousness played a role. This idea unsettled many of his contemporaries. To some, it sounded dangerously close to mysticism. But Heisenberg was careful. He never claimed that human thought created reality. Rather, he believed that observation and reality were intertwined in a way that transcended simple cause and effect. He often compared it to music. The notes on the page are fixed, but the melody exists only when played, when experienced. The quantum world, he thought, was like that melody, its possibilities waiting for the act of observation to bring them into being. In the years that followed, Heisenberg's reflections on uncertainty began to echo far beyond physics. Philosophers found in his work a bridge between science and metaphysics. Artists and poets found inspiration in the idea that reality was not rigid but fluid, shaped by perception and interpretation. Even theologians saw in his discoveries a kind of scientific humility that paralleled faith. the recognition that ultimate truth could never be fully grasped, only approached. Heisenberg himself welcomed these connections, though he remained rooted in reason. He believed that the greatest gift of science was not certainty, but wonder, the awareness that every answer opened the door to deeper questions. The philosophical implications of uncertainty also transformed how Heisenberg viewed human life. He began to see that the same principles that governed the quantum world also applied to existence itself. Every decision, every encounter, every act of understanding was touched by uncertainty. Just as one could never predict the exact behavior of a particle, one could never predict the unfolding of a life. Yet within that unpredictability lay meaning. He saw human freedom as the macroscopic expression of quantum indeterminacy, the space where possibility and choice met. The uncertainty principle, he said, was not just a physical law but a metaphor for existence, that we live not by knowing everything, but by acting with faith within what we can know. As his ideas matured, Heisenberg's tone became increasingly poetic. He spoke of science and spirit as two languages describing the same mystery. The first sip from the glass of natural science may make one an atheist, he once remarked, but at the bottom of the glass God is waiting. For him, the study of nature was an act of reverence. The uncertainty at the heart of the universe was not a flaw in creation. It was the sign of something deeper, something that invited humility. He felt that the true task of the scientist was not to conquer nature but to listen to it, to interpret its language with respect. In his later years, Heisenberg's reflections grew increasingly serene. He had seen his principle misunderstood, debated, and stretched into every corner of culture, yet he remained calm, knowing that its essence was simple. It was a statement about the unity of opposites, knowledge and mystery, order and freedom, observer and observed. He once told a student that the uncertainty principle was like standing on a bridge between two worlds, the solid world of classical thought and the fluid world of quantum reality. We cannot return to the old shore, he said softly, but neither should we fear the sea. The philosophical implications of uncertainty outlived him, seeping into every aspect of modern thought. In the end, Heisenberg's greatest contribution was not only to science, but to the human spirit. He taught that to know is to participate, that to observe is to shape, and that even in uncertainty there is meaning. His principle was a mirror reflecting humanity's place in the cosmos, finite yet connected, limited yet luminous. It showed that the true beauty of the universe lies not in perfect knowledge, but in the endless mystery that invites us to keep searching. The world of physics in the early 20th century was not just a field of discovery, it was a battlefield of ideas, where the greatest minds of the age wrestled over the meaning of reality itself. And at the center of this intellectual storm stood Werner Heisenberg, facing not only the mysteries of nature, but also the giants of thought, who questioned his vision. His most profound struggle was not with equations, but with other brilliant physicists, men like Niels Bohr and Albert Einstein, whose interpretations of the quantum world shaped the destiny of modern science. Their dialogues were more than scientific debates. They were philosophical duels over the very nature of truth. Heisenberg's relationship with Niels Bohr was one of the most intense and fruitful in the history of science. Bohr, the elder statesman of quantum theory, was a man of deep insight and patience, while Heisenberg, younger and fiery, was filled with mathematical brilliance and restless curiosity. When Heisenberg first came to Bohr's institute in Copenhagen, it was like a student entering a temple of wisdom. Bohr guided him with care, challenging every assumption, forcing him to think beyond the safety of formulas. Their conversations would stretch late into the night, echoing through the quiet streets of Copenhagen. They argued about electrons, about waves and particles, about the limits of what could be known. Bohr believed that physics was not just about discovering facts, but about understanding how nature reveals itself through our questions. Heisenberg absorbed this philosophy deeply. It became the backbone of his own thinking. Yet, as their collaboration grew, so did their disagreements. When Heisenberg introduced his uncertainty principle, Bohr at first resisted it. He worried that it might be misunderstood as a limitation of human ability rather than a law of nature. The two men debated fiercely, but through that tension came clarity. Bohr realized that Heisenberg's discovery was not just a technical detail. It was the key to understanding the quantum world. Together, they built what became known as the Copenhagen interpretation, which proposed that quantum mechanics does not describe an independent reality, but only the outcomes of measurement. It was a radical idea. Before observation, particles do not have definite properties. They exist in a cloud of possibilities. Observation is what brings them into being. Heisenberg and Bohr had, in essence, declared that the act of observing changes the universe. But not everyone could accept this new vision. Among the skeptics stood Albert Einstein, whose genius had redefined space, time, and gravity, but who could not accept that God would play dice with the universe. To Einstein, the Copenhagen interpretation was incomplete. It denied the existence of an objective reality governed by precise laws. Heisenberg admired Einstein deeply and was troubled by his rejection. Whenever they met at conferences, their exchanges became legendary. Einstein would present thought experiments, ingenious scenarios meant to disprove uncertainty, and Heisenberg, often alongside Bohr, would patiently explain why each one failed. No matter how clever Einstein's challenge, quantum mechanics held firm, but behind their intellectual sparring lay mutual respect. Einstein once said that although he could not accept quantum mechanics as complete, he admired the courage and brilliance of those who built it. Heisenberg, in turn, said that arguing with Einstein was like climbing a mountain. You learned more from the struggle than from reaching the top. These debates went far beyond science. They were arguments about how the universe itself worked, whether reality existed independently of observation or whether observation shaped reality. To Einstein, the world had to be logically consistent, guided by hidden variables waiting to be discovered. To Heisenberg and Bohr, such hidden order was unnecessary. The universe was fundamentally probabilistic. Its nature revealed only through interaction. The difference between them was not only mathematical, it was philosophical. Einstein sought certainty. Heisenberg found meaning in uncertainty. Their dialogue represented the eternal tension between human reason and the mystery of creation. The collaboration between Heisenberg and Bohr was tested again during World War II, when Heisenberg remained in Germany and became involved in nuclear research. Bohr, who had fled Nazi-occupied Denmark, felt betrayed. The two men met secretly in 1941, their conversation clouded by fear and misunderstanding. No one knows exactly what was said, but both left shaken. For Bohr, it was a moral confrontation. For Heisenberg, it was a plea to preserve scientific integrity in a world gone mad. The friendship that had once shaped quantum physics now carried the weight of history. Even after the war, their relationship remained scarred, yet the respect between them never died. Bohr later said that no one had challenged him as deeply as Heisenberg, and Heisenberg called Bohr the conscience of physics. In those years, Heisenberg often reflected on the nature of their debates, not as conflicts of ego, but as the necessary friction through which truth emerges. He came to see that science progresses not by certainty but by dialogue, by the constant tension between opposing views. The disagreements with Bohr and Einstein had not weakened him, they had refined his thought. Each discussion, each argument, was like a mirror reflecting another side of truth. Heisenberg realized that the quantum world itself was built on this same principle, opposites coexisting, complementing each other, forming a harmony out of contradiction. By the end of his life, Heisenberg had come to see his clashes with other great minds as part of a larger story, the human struggle to understand a universe that is both knowable and mysterious. He saw that Bohr's philosophy and Einstein's realism were not enemies but partners, two lenses focusing on the same light from different angles. In that sense, their debates were not failures, but triumphs of the human spirit, proof that the search for truth is greater than any one man's theory. Heisenberg had lived long enough to see his ideas vindicated, but he never saw them as final. He believed that just as uncertainty was woven into nature, it was also woven into knowledge, that science must always remain open, humble, and curious. Through these collaborations and clashes, Heisenberg helped shape not just the theory of quantum mechanics, but the very way humanity thinks about reality. His friendship with Bohr gave quantum physics its philosophical depth, while his debates with Einstein gave it its moral weight. Together, these relationships transformed science from a search for certainty into a dialogue with the unknown. Heisenberg's life proved that progress is born not from agreement but from courage, the courage to question, to challenge, and to stand in wonder before the mysterious harmony that lies at the heart of the universe. After the turbulent years of discovery and debate, Heisenberg's life took a different shape. The world around him was changing, and so was his role in it. The rise of World War II forced every scientist to make choices not about equations, but about conscience. For Heisenberg, who had dedicated his youth to unraveling the mysteries of nature, this was the greatest test of his life. When the German government began investing heavily in atomic research, Heisenberg was called upon to lead the country's nuclear project. To the outside world, it seemed that the man who had discovered uncertainty now stood in the service of destruction. But inside, Heisenberg's struggle was profound and personal. He was a scientist, not a soldier. He believed that knowledge should illuminate, not annihilate. Yet refusing the position might have meant the end of his career or his life. As the war progressed, Heisenberg found himself trapped in moral twilight. He directed research on nuclear fission, but whether he deliberately slowed the project or simply miscalculated its feasibility remains one of history's lingering mysteries. Some believe he purposely avoided building a bomb, ensuring that the Nazi regime would never possess such power. Others think he overestimated the technical barriers. Whatever the truth, Heisenberg's wartime role has remained a question of conscience. When he secretly visited his old mentor Niels Bohr in occupied Denmark in 1941, their conversation turned cold and uneasy. Heisenberg may have sought guidance or even reassurance, but Bohr interpreted his words as a warning, or perhaps a veiled threat. The friendship that had birthed quantum mechanics was fractured by the moral gravity of war. During those years, Heisenberg carried on with his work under constant surveillance and pressure. Germany's cities were in ruins, laboratories destroyed, communication lines severed. Yet even in those dark times, he kept faith in science as a force for rebuilding. He encouraged his students to focus on the long term, to believe that truth would outlast ideology. In the chaos of war, his lectures became quiet acts of defiance, moments when he reminded his students that curiosity and reason could still exist amid madness. He no longer spoke of atomic equations in terms of power. He spoke of responsibility, of the need for wisdom in the use of knowledge. When the war finally ended, Heisenberg was taken into custody by Allied forces and transported to England as part of Operation Epsilon, along with other German scientists. Confined in a country house and unaware of the outside world, they learned of the atomic bombings of Hiroshima and Nagasaki through the radio. The news stunned Heisenberg into silence. For years he had wrestled with the ethics of scientific discovery, but now the reality of destruction lay before him. The power he had studied had been unleashed, not by him, but by others, and the world would never be the same. Those who were present described him as walking alone for hours after hearing the news, staring at the ground, his face pale. In that moment, Heisenberg saw that science had crossed a threshold. The discovery that had once been the triumph of human intellect had become the shadow of its conscience. When he was finally released and returned to Germany, he found a nation in ruins and a generation of young scientists lost amid despair. He set out to rebuild what had been destroyed, not factories or weapons, but the moral and intellectual foundation of science itself. He believed that Germany's renewal must begin in its classrooms and laboratories, with a new generation taught not only equations, but ethics. He helped to establish the Max Planck Institute for Physics, fostering a community of thinkers dedicated to peaceful exploration. His lectures were no longer about uncertainty in nature, they were about the certainty of moral responsibility. He told his students that every experiment was an act of trust between humanity and nature, and that this trust must never again be broken. In the years that followed, Heisenberg became a symbol of scientific redemption. He traveled widely, speaking not about quantum mechanics but about the relationship between science and civilization. He argued that technological power must be guided by spiritual insight, that science without conscience was blind. He saw parallels between the quantum world and society itself, both governed by balance, by invisible forces of interdependence. He warned that certainty, whether political or scientific, was dangerous when it ignored the mystery of life. His voice was calm but firm, carrying the authority of a man who had seen both the beauty and the peril of human knowledge. Even in old age, Heisenberg never stopped reflecting on the moral dimension of discovery. He often said that the most important lesson of his career was that understanding is never enough. One must also cultivate wisdom. In private conversations, he admitted that the burden of his wartime years had never left him. Yet he found solace in the belief that uncertainty was not only a law of physics but also a safeguard for humanity. It reminded us that control is never absolute, that humility is necessary even at the height of progress. When he died in 1976, Heisenberg left behind more than theories. He left a legacy of integrity, a reminder that science is a mirror reflecting both the brilliance and the fragility of the human soul. His life during and after the war became a moral lesson written between the lines of history, that knowledge without conscience is peril, and that the greatest discovery a scientist can make is not in nature, but in himself. Werner Heisenberg's journey did not end with discovery, controversy, or even moral reflection. It ended with legacy. As the 20th century advanced, the world began to understand that the seeds of the modern age had been sown in the equations of quantum mechanics, and at the root of those equations stood Heisenberg. His work became the foundation upon which new technologies, new sciences, and new philosophies were built. What began as abstract mathematics on an island in the North Sea had become the invisible structure of the modern world. Every transistor, every computer chip, every laser beam carried within it the pulse of Heisenberg's insight. Yet for Heisenberg, this was not merely a matter of technical achievement. He saw his legacy not in machines, but in the evolution of thought, in the way humanity had learned to see the universe as both mysterious and knowable, infinite yet intimate. By the 1950s, quantum mechanics had become the cornerstone of modern physics. It explained the structure of atoms, the behavior of particles, and the origins of energy. Scientists built upon Heisenberg's equations to create quantum field theory, particle accelerators, and the emerging language of information science. The world of electronics, communication, and medicine drew life from the principles he had uncovered. Yet Heisenberg remained deeply philosophical about his achievements. He often said that the goal of science was not to master nature but to understand it, to listen to its harmonies rather than impose order upon them. In his lectures, he spoke of quantum mechanics as a window into the creative intelligence of the cosmos, a system where freedom and law, chaos and structure coexisted in delicate balance. In the post-war years, Heisenberg became an elder statesman of physics, but also a teacher of moral clarity. His presence carried quiet authority, not from power, but from experience. He had seen how easily knowledge could be twisted into destruction, and he dedicated his later life to ensuring that science served peace. He traveled widely, speaking about the responsibility of scientists to act as stewards, not rulers, of knowledge. He urged young physicists to remain humble before the mysteries they studied. When asked how he viewed his own life, he replied that he saw himself as a bridge, linking the classical world of certainty with the modern world of possibility. In his writings, Heisenberg sought to reconcile science and philosophy. He believed that the boundary between them was artificial, that both were driven by the same human need to understand the whole. He drew upon the ideas of Plato, seeing the quantum world as the realm of potential forms, the invisible patterns that gave rise to the visible universe. To him, the quantum field was not empty but full of latent creation, a sea of possibilities waiting to unfold. He wrote that what we observe is not nature itself, but nature exposed to our method of questioning, a phrase that summarized his life's vision, that truth is participatory, that reality responds to the way we choose to perceive it. As he grew older, Heisenberg's thoughts turned increasingly toward unity, the unity of science, art, and spirit. He believed that quantum mechanics had reintroduced wonder into human thought, breaking the arrogance of pure materialism. He saw beauty as a form of truth, and truth as something that could never be fully captured in numbers. He often compared the equations of physics to the compositions of Bach, precise, mathematical, yet filled with emotion. To Heisenberg, the harmony of the universe was not mechanical, it was musical, alive, expressive. In his final years, he sometimes played the piano late into the night, saying that music revealed the same order that his equations once did, only in a different language. The world continued to honor him. Awards, titles, and honorary degrees came from every corner of the globe. But Heisenberg accepted them with quiet detachment, aware that fame was fleeting. What mattered to him was not recognition but continuation, the assurance that younger generations would carry forward the search for understanding with humility. He mentored countless students, urging them to see physics not as a career, but as a calling. When they asked what discovery mattered most to him, he would smile and say, "The discovery that knowledge has limits." To him, that realization was not a boundary but a gateway, a reminder that science, like life, was a journey without end. Even as illness began to slow his body, Heisenberg's mind remained sharp and luminous. He spent his final years writing and reflecting, summarizing a lifetime of thought in essays and conversations. He spoke of how the uncertainty principle, once seen as a challenge to order, had become the foundation of understanding. It taught humanity that perfection is not found in control but in harmony, not in certainty but in relationship. He saw that his work had changed not only physics but the human spirit, teaching people to accept the unknown as part of reality's design. On a quiet February night in 1976, Werner Heisenberg passed away at the age of 74. The scientific community mourned him, but his death felt less like an ending and more like the closing of a great circle. The principles he had revealed continued to pulse through every corner of science, through the glow of every screen, through the whisper of every photon. His name became more than a historical footnote. It became a symbol of the moment humanity learned that knowledge and mystery coexist. Heisenberg's legacy endures not because he discovered uncertainty, but because he showed that uncertainty itself is the heartbeat of existence. He taught the world that precision has limits, that truth is multifaceted, and that every question we ask shapes the world we see. His life bridged the worlds of logic and wonder, proving that science and spirituality are not opposites but reflections of the same human longing to understand. And so, long after his equations are replaced by new theories, the spirit of Heisenberg's insight will remain, a reminder that the more deeply we explore the universe, the more we find ourselves woven into its mysterious and beautiful design.